hope that's okay. That you guys went all right, okay. Okay, yes. Respond to the attendance poll. Well, at least a good thing. It's Friday. It's Friday of week 5, so we are halfway through the quarter. And because we are in the winter quarter, in a kind of a 3-quarter academic year, we're halfway through the academic year exactly. So I mean, I guess you got to tack in finals weeks and stuff. But as far as lecture stuff goes, we're like halfway through. I have posted your next homework assignment. Okay, homework 4. It's available under week 6. Okay, and I have chosen to make it due week 7. Usually I give you guys like a week to do something, a week and 2 days, but I'm giving you a little bit of extra time to get this done. That said, please, like, in your brain, pretend like it's due at the end of week 6 or something. Don't wait until Friday of week 6. I know you guys we have a midterm on Wednesday for this class, and you probably have midterms and other stuff in other classes. Don't just say like, okay, I'm gonna wait till everything else is done and then I'm gonna start like Friday night or Friday of week 6. Okay, this is not an assignment. I mean, maybe you can do it. Okay, but it's an assignment that'll probably take a little bit of time. Okay, the assignment is you're going to so we like board games here, right? So you had Chutes and Ladders, and now we're going to do Monopoly. Okay, and Monopoly, it's just the board movement, so you don't have to plan like, should I buy the railroads or whatever. Okay, you don't have to plan out like decision making stuff. It's just follow the rules. Okay, that's all you're going to do. So there's no decision making, just roll the dice and move. But there's a bunch of rules, okay? There's like, if you land on this spot, you draw a card. The card says you move over here. You do that. Sometimes they send you to jail. What does it mean to go to jail? And there's a bunch of stuff, okay? My encouragement, all right, strong encouragement is read through the directions, read through the rules, and then plan out how you might approach this problem on paper, okay? Don't immediately just start writing up code, okay? Because that's going to get you're going to start doing stuff and then you're going to get into some trouble, okay? You have to use R6, and you're going to be creating this player class object. There's pretty much two things you're going to flesh out, okay? One is your player class, and then the other is taking a turn, okay? And then the rest, like running a game, is just taking a turn a whole bunch of times, okay? And then you'll run a simulation where you run a whole bunch of games and stuff like that. So really, you just have to worry about defining your player class, defining taking a turn, okay? I've already given you a couple things. I've given you the chance card deck and the community chest deck, okay? And those are also reference class objects in that what happens is you shuffle the deck, okay, and then that just takes the 16 cards or whatever, and it randomly sorts them, and then it moves through the deck, and then when it reaches the end, it's going to shuffle it again and start anew. Okay, so that's going to be so I've given you the decks, I've given you the board, and I started off with this just the most basic player reference class, where it says like you move forward and spaces, okay? But you'll want to add more methods and add more fields, right? So for example, probably you'll want to have a field in the player class that tells you whether the player's in jail or not, okay? Because sometimes you'll start a turn in jail, or other times you'll start a turn where you're not in jail. And so you'll want a field probably that tells you whether you're starting your turn in jail or not, okay? I don't know if you guys have played Monopoly, all right? Okay, some of you have, some of you haven't. All right, if you grew up in the United States, you probably did play Monopoly at some point, like at a Thanksgiving dinner or something, I don't know, okay? So you played it with your cousins, and turns out you've been playing wrong your whole life and you didn't know this, but read through the rules, and then just imagine. Okay, so one thing that you can think of is like the fields that I should put in my player reference class, okay? Just imagine you're playing the game, and then you're going to pause the game, so that you can come back and play it later, right? And like, because I don't know, your mom called and said you have to eat dinner now, and so you're gonna say, okay, you stop the game, and then you're gonna come back. Now, when you come back, there's a lot of things to remember, like whose turn was it, and but like as far as your player goes, you'll need to know like where you are on the board, whether that player was in jail or not, and stuff like that. So the things that you need to keep track of, right? So if you box up the game and then you have to unfold it and set it out again, like what are the things you have to remember? Those are probably a good idea as far as like what kind of fields I should include. All right. Anyway, that's that. Get started on it this weekend, all right? I'm happy to answer and help you during office hours and stuff, but if you wait until next week, we're gonna run out of time. So, and the student reviews for the class, there's always going to be some student who says like, I used to like Monopoly, but now I hate it. So I apologize if I ruin your favorite board game for you. Monopoly is just, it's like a C tier game anyway, so we get, when we talk like, all right, anyway. Okay.
What's your favorite board game?
I don't know. So there's this card drafting game called Seven Wonders. I like that. Settlers of Catan are good. That's like a gateway game for your Euro tier games. Ticket to Ride, those are also gateway games, right? So anyway, but I've got kids now and I don't have time for games anymore, so just the reality of things. It's okay. I have different kinds of joy now. All right, we're talking GGplot today, okay? A lot of my stuff today is coming from the R Graphics cookbook. You can pretty much read the entire textbook online at this website, and then also you can also purchase the O'Reilly textbook. It's good stuff. Okay. So GGplot is a package created by Hadley Wickham. It's part of the tidyverse. You load it up, library tidyverse or library GGplot 2. The GG in GGplot stands for Grammar of Graphics, and this is a system created by this person, Leland Wilkinson, and it provides a formal and structured perspective on how to describe data graphics. Okay, I'm a big fan of GGplot. Okay, but I still use base graphics all the time, and base graphics is great. If you just need to make a quick plot and you need to inspect something, base graphics. You don't have to load up library GGplot. I'm not trying to say GGplot is better than base graphics. That's not what I'm saying, okay? I'm teaching, you guys learn base graphics, I'm assuming, in Stats 20, okay? And we're gonna do, maybe you also learn GGplot in Stats 20, I don't know, we're gonna go over this today, okay? All right, the big idea, and I'm gonna say this like numerous times today, is that we map properties of data to visual properties of the graphic, okay? That's what a data visualization does, okay? So if we're gonna make a scatter plot, okay, all right, we gotta start off with tidy data, and when we talk about properties of the data, we're talking about the variables that are stored in the columns, okay? So we might have a variable for the person's height, a variable for their weight, their gender, their race, ethnicity, their hair color, all sorts of variables, right? You can imagine having a data frame with all of this stuff, okay? And then, as far as our graphic goes, for a scatter plot, we have visual properties like the X position, the Y position, the color of the dot, the shape of the dot, I don't know, the size of the dot, things like that, okay? And if we're not mapping properties of the data to visual properties, this is not a data visualization. Okay, so here's just to start off, here's a very simple example. I've got 6 people and I've completely made up some data. I have their height, their weight, their gender, and then their hair color, okay? So we got 62 inches, 120 pounds, female, brown hair, right? Something like this. 67 inches, 140 pounds, female, black hair. And this is how we would produce a scatter plot. We call it GGplot. There's all of this stuff. Data is DF, mapping, AES, X, Y, color, shape, geom point. Okay, I'll get into all of this stuff later. Okay, but we call this command, and this is the plot that it produces. Okay, and we see, so this dot represents what? This is person who is 72 inches tall. Their height is 72. Their weight looks to be 190. What color is this person's hair? You guys can read it. It's a triangle, so it's blonde hair. Okay, and what the gender is, I don't know, this teal color, which corresponds to M, male. Okay, and here's somebody who looks, I guess, 68 inches, maybe 165 pounds. Circle means black hair, and then teal means male. Okay. The power of a data visualization is that it allows our brain to utilize its visual processing abilities, right? So your brain is equipped with like the most amazing visual processor ever. Okay, we are trying so hard to get computers to have vision the way humans do, right? It's challenging just for a computer to look at a picture and say, this is an apple, right? But this is something your brain does super quickly. We've got incredibly powerful visual processing abilities, okay? Whereas as far as numbers go, if you just only look at this, it's hard to just see patterns in the numbers. Yes, you can like study this and go like, okay, larger height numbers tend to be associated with larger weight numbers, smaller height numbers. Like it would take you a while to establish that pattern from just looking at numbers. But when you create a plot like this, you see immediately kind of this upwards trend, right? Like larger values over here go with larger values, smaller values here go with smaller values, and things like that, okay? Because our brain is able to identify patterns and stuff, right? And so the whole idea of a data visualization is that we want to map the data to some visual, okay? And this is the other important part, is that the viewer, we need to have the graphic, this thing that we've created, this plot, the person looking at it has to be able to map the visual back to the data inside their brain. Okay, so and that's the key. Okay, so data visualization, we go, rather than showing the data directly to the person, we go from, which is a complicated process in of itself, right? So the fact that you are able to look at this text and then gain information from it, there's a lot of like weird translation going on, right? Like I had ideas in my head and I had to use kind of like my linguistic abilities to bring it forth into language, and then I put that onto the thing, and then your brain right now is using your language process. Well, first your visual processing that goes into character recognition. The character recognition forms words, and then you're using the language part of your brain to take the information presented on the screen to process that stuff. Okay, similarly, if we go back to this table, you're using your eyes recognize characters, and you're using kind of the language and symbol recognition to do this, and it's harder to kind of detect patterns here. What we are doing is, rather than having to go through the language and character recognition portion of your brain, we're going to the visual pattern recognition portion of your brain. So we're taking that data, we're mapping it to a visualization. Your brain looks at this and says, okay, I see patterns, things that look like lines. I'm able to identify clusters, I'm able to identify groups and stuff like that, okay? And so what's important is when you look at this, we need to be able to go from this back to a representation of the data inside of your brain. I don't know, this is like a little bit high level and philosophical, but this is kind of the thing that Leland Wilkinson in his Grammar of Graphics thought thoroughly about, and he's absolutely right in terms of how we are visualizing and interpreting data from this, right? So when we look at this scatter plot, if I told you, recreate this data table you could, right? You would look at each data point and you'd say, okay, here's a triangle. Triangle means this person is female. This person's height is 65. I look at this number, it's 65. This person's weight is 160. And then the, triangle is blonde hair, and then this reddish orange color, reddish, I guess, salmon color, I don't know what we would call it, would be female, okay? And so we can go back and produce all aspects of our data by looking at this, okay? We don't have to do this and create this, but visually, all of that information is presented here, okay? And by looking at this thing and looking at these guides over here, the legends, our brain is able to do this, okay? So from just kind of a high-level conceptual place, does this make sense? This idea of going from the data to a graphic and going from the graphic to our brains, we are going back to the data, okay? And it's more effective because we're utilizing different parts of our brain that are good at pattern recognition, okay? All right, so we have some terminology, okay? All right, and so the data is what we want to visualize. It consists of variables which are stored as columns. The geomes are geometric objects that are going to represent the data. These are things like bars or lines or points, okay? We have aesthetic attributes. Aesthetic attributes are properties of the geometric objects, things like the X and Y position, the color of the line, or the shape of the point. Those are properties of the geometric object, okay, the aesthetics. The mapping is how we map the data values to aesthetics, okay? There's scales. Scales control how the mapping of values in the data space get mapped to the values in the aesthetic space, right? So as far as the aesthetic space goes for the, the shape of a point, okay, maybe you can have circles, triangles, and squares or something. How do we map the data values to those aesthetic values, okay? And then the guides are how we map the visual properties back to the data space when we look at it, okay? So, so the guides and the space scales work hand in hand, and generally, if there's kind of a non-intuitive scale presented, you need to have a guide so that the user is able to map it back to the data space. Okay, so guides are things like tick marks on the X label, or they're legends with kind of a showing you, this is what a triangle represents. Okay, so when we create our scatter plot, this was the command we used, okay? All right, the geome that we say geome point, which means we are going to use points to represent our data, okay? The data comes from our data from DF, and then this is our mapping. We map the aesthetic attributes of X to height, Y to weight, color to gender, shape to hair, okay? And then when we look at the plot itself, the scales were automatically determined by GGplot, okay? So the scale chooses to make the lower left-hand corner something around 59.5 for height and 118 for weight, okay? So if I go back to here, this lower left corner is something around there, okay? And then the upper right corner is up here, and that's like 72.5 and, I don't know, 192 or something like that, okay? And then as far as the scale goes, GGplot automatically chose like the colors of salmon and teal to represent the genders, and it automatically chose the shapes circle, triangle, and square to represent those hair colors, okay? And because GGplot did that, it also creates guides for us automatically. It automatically labels the axis and the horizontal and vertical axis, and it produces legends for us, okay, which is important. I mean, it seems like we take this for granted, but can you imagine if I just covered up these numbers and I covered this part up, and now you have just a picture with just colored triangles and circles and dots, but you have no idea what any of it represents, right? Just the very fact that I've written height here and weight here suddenly gives this plot meaning, okay? And without those guides, the plot is meaningless. All right. Okay, so just kind of looking at the aesthetic mappings, we've already talked about this. These are aesthetic attributes, okay? The aesthetic attributes include things like the X position, the Y position, the color of the shape, the color of the point and the shape of the point, okay? There's other aesthetic attributes that you can have, and you can look those up when you go to like the help file. You can change the stroke and the alpha, you know, how transparent it is and things like that, okay? The size and stuff, okay? And so here's kind of our scatter plot. This is what we have. And let's just think what would happen. So right now I have the gender mapped to color and the hair mapped to the shape, okay? What would happen if I switch and I say the shape is matched to gender and the color is mapped to hair? Okay? What would happen to the plot? How many colors would now be represented? So the colors, we have 3 colors. We've got brown, black, and blonde hair. Okay? And then genders, in our data said there were 2 genders represented, okay, males and females. Okay? And so if we do this, if we change the mapping, hair and gender, we would get this, okay? So now there are only 2 shapes, circles for females and triangles for males, and then the hair color gets represented with green, red, and blue. All right. Is this okay? So this is, here it is, we have gender is color and hair color is shape, and here gender is gender is shape and hair color is the color of the dot, okay? So it's the same information that's being presented, okay? If I said recreate the data table from this plot, you could also do it, okay? But one thing is that our eyes generally notice color before they notice shape, okay? And so if you're creating a scatter plot like this, it's generally the most important categorical variable should get the color attribute, okay? And then the less important categorical variables should get like the shape attribute, okay? Because here I think we naturally recognize the colors a lot more quickly than we recognize the shapes, right? So yes, indeed, these triangles represent males and these circles represent females, but I think it's easier to see the gender split here when they're colors versus the hair color split here. Right. Is that okay? All right, here's a question. What would happen if I map the categorical variable hair to the y-axis? And what would happen if I map the numeric variable weight onto the color aesthetic? Could I even do this? Okay, so here I'm saying mapping, x is going to be height, so height will still go along the x-axis, but y is now going to be hair. I'm mapping the hair variable to the aesthetic y, and then color will now be weight. Shape is still going to be, shape is gender and color is weight, okay? What would my plot look like now? Yeah.
Does it make weight like a sliding scale of color?
Okay, yes, so weight will become a sliding scale of colors, and then how will I plot things in the y? Yeah.
It would be like three
separate y locations, okay? And this is the result, okay? So here, this dot right here represents a person with a height of, say, 67 inches. This person has black hair. This person is female, and their weight looks to be, I don't know, 100, somewhere between 120 and 140, maybe 130 pounds, okay? So the weight is now this continuous scale where we have dark representing lower weights, and light blue representing higher weights, right? So the heaviest person in my data set is this person who looks to be 72 inches, blonde hair, male, maybe 190 pounds, okay? And then the lightest weight person, lowest weight person, looks to be this person because this dot is the darkest in color. Okay, this person is female, has a height of 62 inches, and has brown hair. Okay, so all of the attributes are there. Okay, but the visual picture that it presents is also very different, right? And so, when we think about this, generally we put numeric variables on the x and the y axis. Okay, because visually we're able to kind of detect patterns like that, spatial patterns that way. But it's not wrong. It's not wrong to map a categorical variable to the y position or the x position. You can do that, but your plot is going to look different. Okay, and so it might feel that representing a number with a y coordinate feels different from representing a number with a color of the point, but on an abstract level, it's the same idea. Okay, we are just taking some numeric value and mapping it to a visual attribute. Okay, and that's kind of the central idea of GGplot, is that we're taking these columns, whether they are numeric or categorical, and we are mapping them to aesthetic attributes of our geometries. And if you get that, then all of GGplot will make sense. Okay, that's kind of the central idea, is that you can map any of these things here, and you do that. Okay. So just in general, so some aesthetics, like the shape of a point, can only be categorical, right? It doesn't make sense to have the shape of a point be some continuous numeric variable. And then other aesthetics, such as the x or y position, can be mapped to numeric or categorical. Even color can be mapped to numeric or categorical, right? For things like the bar graph, the x-axis is going to be categorical generally. For a scatter plot, generally the x and y are going to be numeric, okay? So you want to think about what kind of variable you have and what attribute it should be mapped to. Okay, just a quick comparison between GGplot and base graphics. Okay, so if I wanted to create a comparable graphic with base graphics, I can do it. It's just going to be a tiny bit more work. I'm going to have to create a vector basically for my colors and a vector for the plotting character, okay, the shape. Okay, we call plot, and then I have to make the legends. So this is kind of what the commands would look like. I call the colors, I create a vector of colors using if else. I create a vector of shapes by kind of subsetting the shapes based on the integers of the kind of that factor. And then and I plot using, df $height, df $weight, colors is colors, shapes, pch is shapes. And then I have to create the legend. The legend's also, I don't know if you ever tried to create a legend in R, but it's a little bit time consuming and annoying. Yeah, question?
In the graphic for the one with the weight, do you make the weight a shape, or is it just a person?
So weight, I don't know what would happen. I think it's going to run into problems. If you tried to make weight, which is numeric, into a shape, what would happen? Yeah, it might make bins. Yeah, I'm not quite sure what it's going to have to do. Yeah.
So if you have numeric value, but it's not used as a number, I guess, in terms of doing any sort of math with it, I think we talked about area code or something.
Okay. Yeah.
Is there any way to make that represented categorical?
Yeah. I mean, so if you have something like area code, and it looks like a number in the thing, all you have to do, you can just tell R it's explicitly treated as a category by doing just factor on the column, right? So if you have numeric values, but then you just say it's a factor, then suddenly those things become categorical.
So can you do that with the weight?
You could, and then basically we're creating a category for each person's weight. So that we're saying this is a category for people who weigh 120 pounds. Here's a separate category for people who weigh 121 pounds. Here's a separate category for people who weigh 122 pounds. And we can see we're going to end up like with 200 categories here. And I don't even know if there's 200 shapes. Like I can't, like we got circles, squares, triangles, stars, 5-pointed stars and 9-pointed, I don't know. Like we're going to run out of shapes, right? I guess we could have emojis and we'll have 200 of those, right? But, and I think there's a mod, or not a mod, it's a library where you can do GGplot emoji or something, and you can plot emoji characters for your plot point symbols, and, you know, if you can think it, somebody will make something out of it, right? So, yeah, so I guess we could have 200 plotting characters, but it's, oh my goodness, that would be such a terrible thing on the eyes, because first of all, then your legend would have to have like 200 symbols and exactly what they correspond to, and I don't know, it could work if we're talking about fruits, right? We got a whole bunch of fruit emoji and we want to plot those. Yeah, that would be great, but I don't know, anything else it's going to be hard. So yeah. Okay, what was I saying? Okay, GGplot, base graphics. Okay, basically, you can do it with base graphics and you get this, and it's like the same plot, but, oh man, I don't know if you've ever had to make legends with base graphics. Okay, you don't want to do it. You don't want to do it, okay? So, so GGplot, yeah, there's a little bit, like you got to learn a little bit of the language, but basically you just provided the aesthetic mappings, which once you understand what an aesthetic mapping is, it's very easy to do, okay? If you understand that concept of an aesthetic mapping, then this makes sense. We're going to map each of these variables to each of these aesthetic traits, okay? And we throw that into the mapping section, all right? And then we say make a plot, and then GGplot does the rest for us. It creates the legends, it creates the scales, it creates all of these things, okay? So I'm going to just back up a little, and we're going to just say, let's say we start from scratch, okay? So here's kind of my data frame that I'm working with, the same data frame with the people and their height, weight, genders, and hair color. And here I can create just an empty plot, okay? Here my aesthetic mapping just has X and Y, all right? And when I do this, I haven't put any kind of geometries on here, so there's nothing to show, okay? So if I do this, GGplot, I can just do geom_point, and it's going to put the dots on the people, and this is just the height and the weight. It only shows 2 variables being plotted here, okay? So this is kind of your most basic thing that we can create. One thing with GGplot is that all of these things are objects themselves. And so I could store this original call to GGplot on the data frame and store it as P, and then and I can do P plus geom_point, okay? And then I would produce the exact same plot that I had before. And here, even though I didn't put the color is equal to gender inside this aesthetic mapping, I can kind of add it after the fact to geom_point. So this point geometry, I can say aesthetics, do an aesthetic mapping here where color is equal to gender, okay? And then it does that, okay? So I got these tiny little red dots and tiny little teal dots showing up in the plot, okay? There's something known as settings, okay? Settings is you can take any of those aesthetic attributes and you can just set them, okay? So here I'm going to say color is blue and size is 10. And what this does is it sets the aesthetic attribute of color and size to be blue and 10 for all dots, okay? So these are not mappings, these are settings. And so all the dots become blue, size 10, okay? We can change the scale. So here again, geom_point, I'm not changing any settings, I'm not changing any other aesthetic map. So there's only 2 variables being plotted here. And here you can set the scale, right? So setting the scale tells how the thing should go. So here we're going to say from the lower end will be 60 and the upper end will be 100. And so that kind of just squishes the scale that we have on the plot. Okay, so again, scale is what the aesthetic space looks like and what the data space looks like. And by default, GGplot will generally set your left scale to be the smallest value and your right scale to be your maximum value, but you might want something different, okay? And you can manually set it this way. So the scale is what space does your visual thing represent, okay? And you can have it represent something outside or not enough of your data space, okay? If you think about how the colors get mapped, okay, you can do set the scale on the colors, okay? And so here I'm going to set the color scale to be orange and green. So by default it's like that salmon color and teal color, but now I'm going to say orange and green, forest green, and it'll do that. Here I'm going to map color to gender, and that goes inside the aesthetic, okay? But notice I put size equal to 10 outside of the aesthetic, because this is going to be a setting. So all the points will have the same size of 10, but the color is going to depend on the variable gender. Okay, and so when I do this, now I get these points in green and these points in orange. Okay, and again, you can set these colors manually. You can set your scale manually. Okay. One thing regarding GGplot is you often have to call print itself. Okay, you have to call print on the object itself, especially if you're calling it inside a loop or a function or something. You got to call print, otherwise it's not going to display the plot. Okay, and then sometimes your data has to be transformed or summarized before it is made into an aesthetic. So for example, we're accustomed to just calling histogram or hist on some kind of plot, okay, or some kind of data set. But what is actually happening is R is doing some summary functions, binning up the things and counting them out, and it's plotting the count in each bin. Okay. Now, thankfully, GGplot includes some of these abilities for us. When you call geom histogram, it's automatically going to do all of that summarization for you. Okay. I'm going to just kind of zip through some of this stuff here. Okay. Your three most basic geometries are the point geometry, which we've seen already. There's the line geometry and the bar geometry. Okay, there's other ones like histogram and box plot, and then in kind of the full list, you can go to the GGplot reference guides. Okay, and then also this cheat sheet contains basically a list of a bunch of the I don't know what happened, but a bunch of the geometries that you can use, okay? But again, all of these things, once you understand how the aesthetic mapping works, you can pick up any of these geometries quite easily, okay? So here's a bar graph. Here, we've got one column represents the X position, the other column represents the height of the bar, something like this. And in this case, we're going to use geom bar and say stat equals identity so that it uses the actual value that appears here. All right. So here we go. We got X as the group. The height is determined by the weight. And for the bar, we're going to use stat as identity. Okay. Here's another thing. We've got side-by-side bars. Okay. And so we've got 3 different dates: day 16, day 20, day 21. And we have 2 cultivars, cultivar 39 and cultivar 52. Okay, and then we got a whole bunch of different things. So the y value that we're going to plot is going to be weight, okay? And we want the height determined by the weight, but the fill color will be determined by the cultivar, all right? So we do this, and we get something that looks like that. Here's a bigger data set with diamonds. It's got more variables and like thousands of rows, okay? And if you do geom bar without stat equals identity, then its default value is to kind of count how many times a particular variable appears. Okay, so here we say cut, and it tells you it's going to go through and summarize and say this is how many times I see cut, how many times I see premium, and stuff like that. Okay, here is just some information about states and their populations and how much change there was, I think, between the 2000 census and the 2010 census, and we're going to have the 2020 census soon, and California is expected not to grow very much, but that's fine, okay? All right, and then so you can kind of plot this, and so here I've got X is the state abbreviation, Y is the value, the change, and then the fill is its region, whether it's from the west or the south, okay? And we can change stuff, right? So fill I can plot based on the change, okay? And so the tallest bar, so notice I have Y and fill both to change, okay? And so it's the same information being presented in kind of two different ways. The tallest and lightest color bar is the one with the most change, and the shortest and darkest color bar is going to be the one with the least change. Here I have called reorder. I said X is going to reorder the abbreviation based on change, and it reorders it. I'm going to have to resize this plot, but we can change the order here, okay? And here I've used, I guess, our school colors for kind of color fill manual, scale fill manual, which we've seen. Here we can color, for a numeric variable, you can change from the low end is red and the high end is blue or something, and it kind of fills this gradient and stuff. There's just such a big jump between this one and this one that it looks like a different color, okay? Line graphs, same kind of ideas. The properties that you can do so this is your basic line graph. You have your X and Y position, but you can do things like the color of the line, okay? And you can have different colors lines. You also have like line thickness. Another one that you can do is the line type, okay? So this is a solid line versus a dotted line, okay? Which is useful if you're printing it out on black and white. You can have solid lines and dotted lines and stuff like that. Okay, I think we've seen a lot of the scatter plot stuff. You can change the shape, whether it's circles, triangles, and squares. You can change the size. You can change the color of the point. Here we have different shapes, triangles and circles, but here you can see the different, the blue and the red dots are easier to distinguish. Here the triangles and the circles, I don't know, it just hurts my eyes here, right? Like if I focus, sure, okay, but this just looks like ants on the page. And then the other thing is you can combine data from multiple data frames, combine stuff from here, okay? And basically what you're going to do is you can start off with GGplot based on one data set, okay? So here I create a data set for like a sine graph, okay? And I say plot a line here, okay? But let's say I want to add points, and the points are going to come from a different data set, okay? All you have to do is you take whatever plot you had before, and then you call geom_point, and then you just specify the data is coming from this data set, which I call df of points, okay? And then so you can add those, right? So these are just unrelated points and stuff. You have another data set, okay? So here I'm just creating a bunch of coordinates for x and y to create like starting x and ending x and things like that. And so here I've got another data set called df segments, okay? And I can add that, right? So this plot is meaningless, but the point is that you can update each plot by just adding another point geometry, and you call data from a particular different data set, okay? So you can combine information from different data sets by adding geometries and specifying where that comes from, okay? But again, the key idea is the aesthetic mapping from the data variables to visual properties there. All right, we'll end here. I will post a old midterm from a couple a couple years ago that you can study from, and have a good weekend. We'll see you guys next week.